So, this is the part 2 version of algebraic fractions. We already covered the first bit, so we'll just rehash very quickly over what we went through. We spoke about, first of all, why you need to have the same denominator to add and subtract different fractions, okay? And we spoke about if you eat 2 slices and then 3 slices of an 8-slice pizza, then you've eaten 5 slices. That's very obvious, very easy, right? But then if you've eaten 2 slices of an 8-slice pizza and then 2 slices of a 3-slice pizza, then it's kind of hard to say how much of the pizza you've eaten. You can't tell me, oh, well, I've eaten 2 of the 8 and then 2 of the 3. If I ask you like, oh, well, how much of the pizza's left? You don't know what to tell me, right? It's confusing. So we spoke about that idea of having the same denominator being really, really important. We did a bunch of little basic examples of making the denominators the same. So just the idea of cross multiplying, making sure that, you know, if I have a 4 here and a 3 here, you just do 4 on 4 here and then 3 on 3 here. And the cool thing about this is that it works for algebra as well, as we saw here. So we noticed here that all we needed on this side was just an x on x. So we just multiplied everything by x on x, and it works with algebra very nicely. Now, the next thing we looked at was a little bit of multiplication. Now, does anybody remember what I said? It is on the board, but does anyone remember without reading the sentence on the board? What did I say about multiplication? You should never do what, and you should always do what? Anybody? I want you to drill this into your head. Never expand, always factorize, okay? Always start these questions by factorizing, and I think I'll write that as a little red point here. Always start these questions by factorizing before expanding. Sorry, I said then expanding, not then expanding. Factorizing first and then multiplying and crossing anything off from the numerator and denominator. That's the same. Everybody cool with that? So now we said that we're going to move on to division. And after we finished division, we finished all of algebraic fractions. So there is literally nothing else. So you can see it's quite short. And then going back to the syllabus that we're following, you can see that we will have finished this idea of simplifying expressions involving algebraic fractions. So the goal is to finish that today, and we're going to do a bunch of really hard examples so that you guys don't get caught off guard for any of the questions you can possibly get about this. Okay? So let's look at division. So I'm going to make a claim to you guys, and the claim is that dividing is the same as multiplying by the reciprocal, okay? And big sentence, let's break it down and understand the mathematical components of what I just said. So now, as always, I don't say things unless I can prove them to you. So let's understand this statement. Let's prove this algebraically, and we're going to do that with a number example, okay? So Chris, can you just give me 2 numbers to divide? Just pick whatever you want.
4 and 8.
Cool. So let's do 4 divided by 8. Now, instead of 4 divided by 8, which is the same thing as writing 4 divided by 8, what I'm claiming here is that 4 divided by 8 is the same as 4 times, what's the reciprocal of 8? Ava?
1 over 8.
1 over 8. Good. So instead of 4 divided by 8, I'm going to say, no, it's 4 times 1 over 8. So let's see that. 4 times 1 over 8. Now, from our multiplication of fractions, can I multiply those 2 fractions together? Can I? Layla? Can I multiply those 2 together? Why do you say no?
Because we've got 4 over 1, they don't really have a common.
Do they need to have a common denominator when we're multiplying? No, so we can multiply them together. When you multiply them together, what do you end up with?
4 over 8.
And isn't that what we started with?
Yeah.
So is multiplication by the reciprocal the same as division? It is. It's the same exact thing. Okay? Now, this is going to be very helpful to you. However, I don't know why, and I still to this day can't wrap my head around this, but when I was in year 11 and 12, I could not do division as multiplication by the reciprocal. I would get it wrong every single time, and I don't know why to this day, because now I look at it and I'm like, oh, this is very easy, but I used to get it wrong almost every time. So then I learned a different method, which is the rainbow method. I'm going to teach you guys both methods, and you just pick the one that makes more sense to you. You guys can pick and choose. They will both give you, and they should both give you the same answer. It's also good to know both methods because you can use one method to check the other, okay? But, sometimes for some reason your brains just won't be able to process one of the methods, so I just want to make sure that you guys have everything in your toolbox. So, now, let's look into how this applies to algebra. So we see an algebra problem like this, and it initially looks a bit weird. What do you mean fraction divided by a fraction? But just remember, division is the same as multiplication by the reciprocal. So there is two ways you can go about this. There's two methods to solve this question. The first method is multiply by reciprocal. So remember, it's always the reciprocal of the second fraction. Notice we didn't reciprocal 4, we only reciprocal 8. So you only reciprocal the second fraction because it's multiplication by the reciprocal. You keep the first fraction the same. So it's like first fraction divided by the second fraction. No, not divided, times the reciprocal. Same thing, okay? So the first method is multiply by the reciprocal. The second method is make a mega fraction. That sounds scary, but for some reason I found this easier in year 12, but it's kind of per person, each person will find it one method better than the other. So let's first look at the multiply by the reciprocal method. You keep the first fraction the same, and you swap the second fraction to be 3x plus 9 divided by 2x plus 4. Okay? And then what do you end up with? You end up with something that you can now do very easily. We all know how to do that, right? So a reminder, back to multiplication. What's the first step? Someone tell me. Factorize. So I'm going to factorize every single one. So 5x plus 2, 3x plus 3 times 3x plus 3, 2x plus 2. Is there anything I can cross off immediately? Layla, anything I can cross off immediately?
The x plus 3s.
Cool. What about you, Andrew? Anything else?
X plus 2.
Cool. Chris, anything else?
No.
Have another look.
The 3
Yeah, beautiful. 3 and 3 I can cross off. So I'm just left with 5 on 2. Everybody see that? And that's my final answer. So that's the first way you can do division, okay? That's the first way. The second way you can do division is by making a mega fraction. So we know that this just means this over this. Everybody agree? So I can write that like a mega fraction. So I can do 5x plus 10 all over 3x plus 9 all over 2x plus 4 all over 3x plus 9. Okay, so I've made it into a mega fraction. And all you do is you multiply the very top and very bottom. That becomes your numerator. And then you multiply the middle two, and that becomes your denominator. Personally, as I said, I used to find this mega fraction method easier, but now I actually prefer the reciprocal method. Okay, so I think the reciprocal method's a bit cleaner just because it turns it into a multiplication problem. But you'll notice as well that so does this one. So notice you're multiplying 3x plus 9 and 2x plus 4. You're doing the same thing here, 3x plus 9 and 2x plus 4, that becomes your denominator. And then you're multiplying 5x plus 10 and 3x plus 9, and that becomes your numerator. And you notice it's the same thing over here. So these methods mathematically do the same thing. It's just a matter of they look different, and to some people one might make more sense than the other. Okay, so again, when multiplying these, again, don't expand. You should always factorize. So the multiplication for the numerator would literally just be the factorized version of 5x plus 10, which is 5x plus 2, and then times by the factorized version of 3x plus 9, which would be 3x plus 3. And then you do the denominator as well, so 3x plus 3, and then times 2x plus 2. And then same thing as before, you're going to cross off your commons. So x plus 2, x plus 2, x plus 3, x plus 3, and then 3 and 3. And again, you end up with 5 on 2, which you should, okay? Now, can someone remind me how would we check the answer to our question? Can you check the answer to all algebraic anything questions, anything algebraic? Chris, you know the answer. How do you check algebraic questions?
Yeah, you just plug them in with a random number.
Correct. You pick a random number for x. You can pick like 1. If you plug in 1 for x, you should get 5 on 2. If you plug in 10 for x, you should get 5 on 2. If you plug in 15 for x, you should still get 5 on 2, because the whole point is that all the x's end up cancelling each other out anyway. Okay? So that's how we would check our algebraic questions. So that's literally the end of algebraic fractions. That's everything. But we also want to now do a bunch of examples, because I want you guys to be guns at these types of questions, because they show up quite often, especially in the first year 11 exam. Okay, they show up really, really often. So let's do that. So can I get everybody to start with this question? So start with this one, so it's slightly easy, and then we'll move on to some harder ones. So one of you guys wrote this as your response. Let's go through it and talk about whether it is correct or incorrect, why, and then this will give you guys the ability to learn other people's mistakes. So step 1. This person multiplied by 2 on 2 here and 3 on 3 here, and I can see that they've done that to make a common denominator. That's perfect. Next step, they have placed this in brackets and this in brackets. You can also expand, don't have to though, so that's perfect. So that step is great. Next, they have put the fractions together. That's perfect. Next, they have expanded correctly or incorrectly. What do we think? Anybody? Correctly or incorrectly, what do we think?
Incorrect.
And why?
They didn't do the 3 times 1 for the x plus 1.
Uh-huh.
So it should be 3x plus 3, because 3 times 1.
Uh-huh. And by any chance, do we see what they did do? Because I can see what this student's done. I know what they were thinking when they did this. Does anyone think they know what they were thinking when they did this? I think what they were thinking is, oh, well, 6 is made up of 3 and 2. So I'm just going to cross the 3 off with the 6 and cross the 2 off with the 6. So it's just back to being a 3. And then I'm going to leave the 3x plus 1 and the 2x plus 4 there, the original brackets. I think that's what the student was thinking. And that's a mistake. You can't cross things off if there's an addition symbol. Can only cross off when there is only multiplication in the numerator and denominator. If there's addition, you can't cross it off. Okay? When I say if there's addition, you can't cross it off. If the addition's in brackets, that still counts as multiplication because it's a number being multiplied by a bracket. So we went wrong down this step, and so we got the wrong answer. If this was, let's say, a 2-mark question, this student would still get 1. Let's correct their mistake. From here, you would have to expand. I know that I said when you're doing multiplication never to expand, but there is a few times where you have to use better judgment and say, okay, well, there's really nothing I can do from here other than simplifying the numerator. So you simplify the numerator. You go 3x plus 3 plus 2x plus 8 all over. Now, I just want to double check. I think, just want to see if I've done this correctly. Oh no, this is very, Actually, I've just realized this is also wrong because the 2 changed to a 4. So something's wrong there, okay? So maybe actually the student would get 0 just because they made that little error there. So it should be 2x plus 4 all over 6. And then you add everything in the numerator together. So you get 5x plus 7 all over 6. And that's it. That's fully simplified. Okay? So we can start to see the common mistakes that students make. That's fine. Correct it in the next one. Yeah? So if anybody didn't get that answer to begin with, I think we know how to correct it. I hope everybody understands how to. Yes. Okay, good. So let's go through another one. Alrighty, so now can I get everybody to try this question? So this student, let's take a look at what they've done. They've multiplied this by 3 on 3, and they've multiplied this by 6 on 6. Good approach. You don't have to do that. What do you guys notice? What's the lowest common denominator between these two? Anyone? Can't you just multiply 3 by 2 on 2 to get 6? So that would have been quicker. It's not wrong though, so this is correct. Let's see how they've expanded it. They've said 12x minus 6 on 18, that's correct. And then they've said 6x plus 3 all over 18, also correct. So that's good. Next one, they've done 12x minus 6 minus 6x minus 3. I like to see that this was expanded, so that's correct. And the last one, they've said that 12 minus 6 is 6. Minus 6 minus 3, they've said is positive 9. That is incorrect. Minus 6 minus 3 is negative 9, okay? Think about it on a number plane. If you start at minus 6 and you move 3 to the left, you're at minus 9, okay? So, this should be a minus. And now, can anyone tell me what has this person forgotten?
Simplify further.
Yes, good. So, the last thing that you need to do is factorize the numerator and then see if you can cross anything out with the denominator. So, what you have to do is sub out maybe, I think a 3 would be the easiest thing to sub. So, you get 2x minus 3 all over 18. And then what's 3 divided by 18? Anybody? 6. Cool. So then you get 2x minus 3 all over 6. And that's it. That would be the final answer. So I'll see if anybody did get that as the answer. Another person also did stop at 6x minus 9 on 18. So again, to the people who did stop here, please make sure that you fully factorize and simplify. Someone else did something weird. Very interesting questions we've gotten for this question. I mean, interesting answers. That's okay. We'll keep going until we get them right. So let's keep going. Does anybody have any questions for me? Because some of you guys are getting them wrong. Does anybody have any questions about how I'm doing this? Or is it starting to make a bit more sense that now that I'm going through the answers? Does it make a little bit more sense? Yeah? Cool. All right, let's go through some more questions. All right, this is another similar question. This is the last style of this question, and then we'll move on to different styles of questions. Try your best to take in everything I've gone through so far and see if you can get this question right. First step looks great. I like that. I like this working out. Second step, perfect. Yes, good. Third step, they've expanded the brackets and it looks like they have expanded this 12 wrong. -4 times -3 is positive 12. So there's the only mistake this person's made. Excuse me. And then finally, we've got 10x minus 8x is 2x. They've, again, gotten this part wrong just because of that one mistake they made up there, but the 20 is correct. So literally all this had to be was this should have been plus 5 plus 12, which is plus 17. So this should have just been a plus 17. Other than that, this person's gotten it right, okay? And everybody else did get the plus 17, which is good, okay? So I hope that this has been good for you guys to see the common mistakes you make. Let's go through some different styles of questions. Okay, so 2 questions now. These will use a little bit of your understanding of factorization. So this is testing more than just fractions. It's also testing factorizing. Just to make it clear as well, guys, this is a 9. I'll just draw a little arrow. 9. Okay. The bottom ones are A's. So only that one is a 9. Everything else are A's. So, as I said, this is factorization problem. You have to factorize before you can start crossing things off the numerator and the denominator. This person pretty much got the right answer. Does anyone see what they forgot? Look at part A. This is their answer. Anyone see what they forgot?
Crossing out the 2 A's.
Yes. So literally all you had to do, cross out the 2 A's. And then you would have had the completely right answer. So that's correct. So all you do is you factorize numerator, factorize denominator, and cross off the common brackets, and then cross off anything else that's common too. Now this next one is wrong in a really interesting way. First of all, the numerator, they noticed it was a difference of 2 squares. That's perfect. The denominator is where they went wrong. When I expand a plus 3, a minus 4, if I expand that, I get a squared minus 4a plus 3a minus 12. What's minus 4 plus 3? Negative a. Negative a minus 12. But it's supposed to be? Positive a. So, as it turns out, this person literally just copied the question down incorrectly. Okay? So, be careful for stuff like that, because technically, they did get the right answer for the question that they answered, but they answered the wrong question. But for the question that they answered, they technically got the right answer. But be careful with stuff like that, okay? So, also a common mistake, as silly as it sounds, misreading the question. Super common exam mistake, okay? So definitely something to watch out for. Alrighty, let's keep going. A reminder in case anybody did forget how to factorize the denominator anyway. So if we have something like a squared plus a plus 12, minus 12. In case anybody forgot how to factorize denominator, step 1 would be, because this is monic, remember if it's monic, you can so simply factorize it, because all you need to do is just find 2 factors of this number that add to give you this number. So the factors would be 4 times 3, specifically 4 times negative 3, because 4 minus 3 is positive a. And then you literally just put it into brackets. A plus 4, a minus 3. If you guys couldn't do this question because you couldn't factorize a quadratic, that would definitely be a sign that you do need to go back and consider relearning factorization of quadratics. Okay? Let's keep going with some more. Alrighty, this is the next question. Now, if you guys do have trouble with this one, because this is something that we just learnt, which is division, just a reminder, it is just multiply by the reciprocal, which means since it's just multiplication, your first step should still be to factorize, okay? And then you can choose either using that rainbow method or you can use multiplication by the reciprocal. But because we just learnt it, if you are confused and you have no idea what to do, please ask questions. Don't write random stuff. Just ask some questions and we'll see if I can help point you in the right direction. This student's done an interesting mistake. Let's have a look at it. So, first step, they factorize, and based on what I can see, I believe they have factorized from the get-go. Something has been factorized in a bit of a funny way. First of all, I see here what I'm assuming is a 5, but what I'm hoping is a 3. So we're gonna go with the fact that it's a 3. If it is a 3, then that would be correct, because 3 plus 2 is 5, and then 3 times 2 is 6. So I'm going to say that that's a 3. Now, looking at the denominator, that's where I see the real big issue. I'm not quite sure what the student has done here, because if you look at this denominator, we should be able to immediately pick out that it is a difference of 2 squares. Okay, and you should see that it's c squared minus 4 squared. And so you should be able to just say that c plus 4, c minus 4. Okay, so that is going to be swapped here. So c plus 4, c minus 4. So it's definitely looking like some of you guys definitely have to go and review some of that factorization, which is fine. You guys have heaps of time before year 11 starts, so get on top of that. Now, when they changed the division into multiplication, they didn't actually reciprocal. So it's multiplication by the reciprocal. So if you're going to change the divide into a multiply, you have to actually multiply by the reciprocal. So this should say c minus 4 on c plus 3. That's what it should say, okay? And then let's just go from here. if we were to fix the factorization, we'd get c plus 2, c plus 3, all over c plus 4, c minus 4, times by c minus 4 on c plus 3. And then you guys can see that I cross off the c minus 4, c minus 4, c plus 3, c plus 3, and I end up with c plus 2, c plus 4. Okay, so I do see that some people did get that answer, which is great. Someone got c minus 2, c plus 4. I think that was you. Somebody tried to do the rainbow method, but seems to have gotten confused somewhere along the lines. To the person who did the rainbow method, I don't know who it was, but to that person, you have to factorize before you can use the rainbow method, okay? And then somebody did get the c plus 2, c plus 4, which is good, and then another person got it, which is good. Wait, that other person was me. We hope that I got it. So only one person got the completely correct answer. Ava, you got fairly close. The other two people, I don't know who is anymore. So for the other two people, I would say very important to go through factorization again. Okay? Let's do, maybe we'll go through 2 more questions and then we'll move on with the content. Now, this is a seemingly very mean question. What I'm going to say to you about this one is simplify like it's 2 separate fractions, then join them together at the end. So my strategy, I'll tell you guys what my strategy will be for this question. So this is something called a compound fraction. So it's a fraction on top of another fraction. I called it a mega fraction before. Doesn't matter what it's called, okay? Moral of the story, you have a fraction over a fraction. Start by just simplifying this fraction. I think everybody knows how to simplify t minus 1 on t. Make a common denominator, t, and then, or you might need to make it, oh no, you can just make a common denominator of t. And then you should be able to, there will be some factorization involved, and then that should be fairly simple. Same thing here, factorize this, I think, sorry, not factorize, simplify this. I think everybody will know how to simplify that. And then piece them back together. So whatever you get here and whatever you get here, put them over each other again, and then simplify from there. Okay, so when you see a question that looks really horrific, don't get scared by it. It's usually just got more steps. It's not necessarily harder. Okay, so go ahead and give this question a go, please. Now, I think it's very important for you guys, first of all, to understand why I'm doing this. It is mainly for you guys to also get into the mind of a marker. If you know how your marker is thinking, then you also know what is good and what is not good to write on your piece of paper. So from the perspective of a marker, when I look at this, it's not clear to me what the student has done. I don't really know what's happened. I think if this was a student and I was marking their work, what I would have preferred to see is denominator, sorry, not denominator, is numerator. So you tell your marker, I'm separating it, because you don't have to separate it. You've chosen that strategy. So you need to tell your marker, numerator, denominator. Everybody cool with that? So you need to make sure to tell that to your marker. Now, looking at what they've done to the numerator, let's look at their simplification for the numerator. On the numerator, I've got this, which is correct. So this is the same as this, so that's good. Now, when they made t a common denominator, they should have multiplied this by t on t, but instead they multiplied it by 2 on t, which is interesting. So remember, t on t gives you t squared on t. So it should have been multiplying this by t on t, and then you should have gotten t squared on t minus 1 on t, which equals t squared minus 1 on t. So that should have been the numerator. Same exact thing for the denominator. So I think what's happened here is that this student forgot that t times t is not 2t, but t squared. I think this student's forgotten that, okay? Looking at the denominator, we end up with t squared on t plus 1 on t, and again we end up with t squared plus 1 on t. Now, there is 2 ways to go about this. You can either do multiply by the reciprocal, or you can do fraction on a fraction. I'm going to do multiply by the reciprocal. So I'm going to take the numerator, keep it the same. So keep the numerator the same. Multiply the flipped version of the denominator. So t on t squared plus 1. And now I can cross the t's off. Can I cross anything off from here and here? Can I cross off the t squared?
Yes.
No. Why? Why can't I cross off the t squared? Andrew, do you think you might know why not?
Probably because you'll be left with just 1, which is basically nothing.
No, not quite. 1 is not nothing. 1 is 1. But if you cross off the t squares, do you see how they're attached to a minus and a plus? You can't do that. You can only cross things off when they're being multiplied. So do you notice how I'd put brackets around all of this? And so I can cross off the t brackets. I can't cross off just part of this bracket. If I want to cross off a bracket, I have to cross off the whole bracket. If I can't cross off the whole bracket, then I can't cross off anything. So then the final answer would literally just be t squared minus 1 all over t squared plus 1. And in my working out, I did factorize this, but you don't actually have to. And then you can't really cross anything off anymore. So you just kind of leave it like that. Everybody cool? Alrighty. So we're going to do one final questions on fractions, and then we're going to move on. Alrighty, can you guys please go ahead and do this question? Keeping in mind it is addition, so you will need to find a common denominator. Start by factorizing, that's my hint. Yeah, it doesn't matter. I'll figure out which one you put on the page. Alrighty, so this student has done something very interesting, which I would not normally do, but it is also not incorrect. So the way I would have started this question is by first just factorizing this denominator. Specifically, I would have factorized it into x plus y, x minus y. That shows us that this is missing an x plus y. This student just figured that out in their head, which you can do, that's fine. I wouldn't recommend it because when you do things in your head instead of writing them down on paper, you're more likely to make mistakes, but that doesn't necessarily mean that you will make a mistake. So this step is correct. The next step, we have on the denominator, we've combined 3x and 2y, and yeah, all looks good to me. It looks great. I'm going to double check it with my method. So just to show you guys an alternate way of working out. So you would have rewritten the question and then change this to x plus y, x minus y, all over x minus y. And this is just for the people who don't understand how this person figured out that you should multiply by x plus y. The way they would have done that is done this first in their head probably, and would have thought to themselves, well, okay, I know that this is this is x plus y and x minus y, so I know that this one's just missing an x plus y, which is what I said before. So x plus y on x plus y, and then x plus y all over plus 2 minus y. I get something slightly different to this person. Little mistake. So a little mistake this person's made, which I've just caught by doing my own working out, is that this minus magically turns into a plus, and I don't know why. So to this person, I don't know who they are, but to this person, I think what's happened here is that they've thought to themselves, well, if the minus expands, so does the plus. But think about what is plus minus y. It's still just minus y. It doesn't magically turn into a plus. Okay, so when you expand a negative into 2x minus y, negative times negative makes positive. So then this would change into a positive. But positive times negative stays negative. Doesn't do anything. So positives can't change anything. Only negatives can. So other than that, the y's should technically not be there because they should cancel each other out, as you can see in my numerator. So I'll continue my working out. You get x plus y, x minus y. And then finally the y's cancel each other out. And that should be a 2x, my apologies. And then you get 3x, x plus y, x minus y. So Very minor mistake there, but again, would definitely cost you a mark. So something to keep in mind there. I think that person has a little bit of confusion about that, but that's okay. I think it's cleared up now. Alrighty, so that's all the questions we're going to do for fractions today. I'm going to set some more questions on that. I'm going to try and set you guys roughly 50 questions on this. You don't have to do all 50 of them. If you do 10 of them and you get every single one of those 10 correct and you found them really easy, great. Move on to the last 3 because I'll always put them in order from easiest to hardest. If you move on to the last 3 questions and you still get them all correct, great. You can move on. You're great at fractions. However, if you do the first 10 and you're getting every second one wrong, I would then recommend please to make sure that you then go through that booklet and start to ask me questions. Hey Marianne, I got this question wrong. I don't really know how to get the right answer. Can you help me? And that would be something I would highly recommend doing. The more questions you ask, the better it is for you. Okay? So that is all of fractions. Let's go through our syllabus and just see what we've ticked off now. So now looking at our syllabus, I can see here that we've finished expanding, factorizing, and simplifying. And we've now also finished simplifying expressions involving algebraic fractions. All right? So that's everything that is in this booklet. Okay? We've also obviously done surds as well, so we've gotten pretty much all the way up to here. Yeah, I don't know. Did I do quadratic equations with you guys yet? I don't think so. Completing the square using quadratic formula. I don't think I got up to that yet. Did I?
I'm not sure. I think you did formula.
I did look at the formula, but I didn't give you guys any information about it, I don't think. I also haven't spoken at all about the discriminant. So we've finished all of this so far. But this stuff was in another booklet. Okay? So what we're going to move on to now is our index laws. Once we're finished with index laws, we're going to move past this stuff rather quickly because it's not hardcore algebra anymore. It's a lot more understanding stuff. These 4 dot points at the start is quite hardcore algebra. It is testing, can this student who is completing these 5 dot points, solve really high order, difficult, challenging algebra questions? If they can, great. If they can't, they need to keep practicing. These are more like, does this student understand blah, blah, blah. Understanding is always easier than things that have lots of practice because the things that have lots of practice require a lot of consistency and a lot of time. Okay? So we're going to now move on to index laws.